Hi, today we're going to be talking about sampling distributions. The first thing to know about sampling distributions is the difference between a parameter and a statistic. A parameter is a value that describes a characteristic of a population, while a statistic is a value that describes a characteristic of a sample. A sampling distribution of a statistic is the distribution of values of the statistic in all possible samples of the same size from the same population. These usually take form of simulations that we can then extract data from to answer questions like, how good is this statistic as an estimator of the parameter? We must also be able to determine if a parameter is an unbiased estimator. A statistic used to estimate a parameter is an unbiased estimator if the mean of its sampling distribution is equal to the value of the parameter being estimated.
The sampling distribution of a statistic is the distribution of the values taken by the statistic in all possible samples of the same size from the same population. Generally, it is too difficult to get all samples n, so a simulation is used. The variability of a statistic is described by the spread of its sampling distribution. This is determined by the size of the sample. Larger samples give smaller spreads, and smaller samples give larger spreads. The more samples that are taken, the closer the sample will be to normal, and the less spread it will have. On the other hand, the mean of the sampling distribution will always equal the mean of the population. Spread is affected by sample size, but mean is not. When the statistic is a categorical variable, we use sample proportions. The statistic for sample proportions is p hat equals the count of successes in a sample divided by the size of the sample. The mean of this distribution is the value of the parameter, and the standard deviation of the distribution is the parameter times the complement of the parameter divided by the sample size, all under a square root. Make sure to check the 10% condition and the large counts condition before performing the familiar probability calculations on a problem.
When the statistic is a quantitative variable, we use sample means. The statistic for sample means is simply a given value to construct a sampling distribution, and it is written as x bar. The mean of the sampling distribution of x bar is the mean of the population mu sub x bar equals mu, and the standard deviation is the standard deviation of the population divided by the square root of the sample size, sigma sub x bar equals sigma over the square root of n. Make sure to check the 10% condition again, because the large counts condition is now satisfied by the central limit theorem that requires the sample size to be greater than 30 for the sampling distribution to have a normal shape.
Here are some AP exam tips and tricks. 1. Terminology matters. Sample distribution has a different meaning than sampling distribution. You want to make sure you do not misuse these statistical terms. 2. Notation matters. Use each symbol such as p hat, x bar, p, mu, and the subscripts of the terms. Use the correct notation or do not at all. You should expect to lose credit for an incorrect notation, so make sure you know the correct one. 3. Be sure you understand what central limit theorem does and doesn't say in context to the problem. Here are some cautions or common mistakes when answering problems on sampling distributions. 1. Population distribution and the distribution of sample data describes individuals. A sampling distribution describes how a statistic varies in many samples from the population. Use pictures of sampling, and population distributions and describe the differences. 2. Taking a larger sample does not fix bias. A large sample of voluntary response or convenience sample would still be worthless because of bias. 3. If the population distribution is normal, then so is the sampling distribution of x bar no matter what the sample size is.